Hello.
Oh, hello, hello. How you doing, Wendy?
I am good. How are you?
Doing good.
Awesome. Awesome.
All right.
Awesome.
Just trying to get everybody else in the group.
Sounds good.
All right. So, how was your week?
It's been good. It's been crazy, but it's been good.
Nice. Those were the best weeks.
Yeah. Yeah. Somebody forged my signature on a document and charged $60,000 worth of stuff to to the company I work for.
Oh, geez. Wow.
That was that was today's adventure.
Yeah, that's definitely yeah, that's concerning for sure.
Yep. Yep.
Man, I hope that you can. I hope everything works out. Jeez, that's
I
nuts.
I think we've got it all figured out now, but I was like, what? They're like having me look at my signature and the signature on the document. I was like, well, I don't spell my name that way, but that looks like they tried to go for my name. So,
Jeez.
yeah,
Wow. Oh, man. Well, I hope they find the verdict.
crazy. Yes, yes, I think they're tracking them down now.
Yeah, wow. Jeez, that's not cool at all.
Mm-mm.
Hey, what's up, Quentin?
Hey,
Man, I got some cool beats in the background, man. Sound good. All right, we're gonna see if we can invite one more person. All right, let's see if I can invite Stylen. All right. All right. I've initially sent them an invitation, so I hope it works out.
Sounds good.
All right. Well, I guess everybody excited for the exam? I know I'm not really excited. I hope it works out.
Mm-mm.
Yeah.
I'm hoping for the best.
Yeah, that's true. Me too. I agree with you completely. Well, I guess we could probably just start off a little bit, and then when they come in, and then we'll probably just review over the questions that we that they may have missed. I guess did you guys have like any questions about like the homework at all, or I want to review any of the questions regarding that, or do you just kind of want to go straight to the quiz?
I'm good with going to the quiz. I kind of get what's going on, but
Yeah,
I learned more from just going to the quiz, honestly, than just that's just how I am.
yeah, no, I'm the same way too. I just find that the questions are probably a little bit more. They're actually harder. I find that they're harder in the quiz than sometimes, but I think
Mm-hmm.
the quiz is actually just covers a large basis. So
Mm-hmm.
for sure,
Mm-hmm.
yeah, we can definitely do that. All right, I am gonna log on to it right now, and I guess, yep, okay, all right. Just gonna also open up the. Okay, there we go. 14. Perfect. All right, I am there. All right. Oh, okay, no worries. Not a problem, then Clinton. No worries, man. Hey, I didn't mind it. It was all good. I was just joking. But hey, that's cool too. No worries. So I guess we'll just start off with the first question, which is question number 4, and I guess I'll start us off. What requirements need to be checked when performing an ANOVA, a hypotenuse test? Mark all that apply. So simple means are all positive. Data in each group are normally distributed. Variance are equal in each group. Um, so I believe it would be data in each group are normally distributed and variance are equal in each group. What do you guys think about those two? I think it would be those two. I'm actually not completely sure about the first one. Sample means are all positive. I
I,
mean,
I think it's the last two. I don't think that they need to be positive. I think it just
yeah, I
the last
believe so
two.
too. I mean, like when I read through the when I read for the lesson, Yeah, the only thing that needs to be positive is the F distribution, I believe.
Okay.
Yeah, so if you look at the 3.1 F distribution, like that's something I was thinking about too. It says like it has to be right skewed, sorry, and then the values of F are never a negative.
Okay.
So that's just for the F distribution. So I don't believe the sample means, as it's indicating in this one. Yeah.
Positive.
Yeah, I don't believe so. What do you think, Clinton? Do you think those two are good? Two BC. Yep. Awesome. Yep. So it would be, yep, it would be B and C. Yep. That's right. All right, moving on to the next one.
We missed
Sorry.
3. Did you already answer 3?
Oh, wow. Yeah, I completely missed that. So question number 3. In the ANOVA hypotenuse test, we reject H when there is sufficient evidence to indicate at least one mean is different from the others. Yeah, I believe that to be true.
Yeah,
Would you guys? True. Yeah, perfect.
I would say true. Yep.
Awesome. Okay, who would like to read question number 5? Would you?
I got it.
Okay.
To check if each group is normally distributed, do the following: construct a scatter plot for each of the data in the group, construct a histogram for all the data, or construct a QQ plot for each group. And I think it's the last one, construct a QQ plot for each group.
Yeah, that's what it says instead of the textbook too.
The textbook.
Yeah, that's right. Creating a QQ plot for each group separately. Yeah, that's right. All right. Number 6, we assume the variance in each group is the same if the following happens. The sample variance for each group is smaller than the sample mean. The largest variance is less than 4 times the smallest variance. The largest sample mean is less than 2 times the smallest sample mean. Each group has the same sample size. I think it would be the second one. The largest variance is less than 4 times the sample, smallest variance. I believe it would be that one. Yep.
Yeah.
Yep. Yep, even Clinton said B, so we're good. All right, so question number 7. Would you read that, Wendy?
You got it. An ANOVA hypotenuse test is whatever. It constructs an independent 2 samples t-test between each pair of samples. If there are 3 samples, there are 3 pairs. 1, 2, 1, 3, 2, 3. How many pairs are there when there are 4 samples? I think 4. 6?
Yeah. 6?
Yeah.
Yes.
Actually, so how did you guys get 6 out of sorry, I just need a
So if you do the pair, so if you do sample 1 is paired with sample 2, and sample 1 is paired with sample 3, and then sample 1 is paired with sample 4. So that's 3 pairs. So then you move on to 2. So 2 and 3. That's 3. The last one was 3 pairs.
Okay.
Each one is paired twice. That's what I noticed.
Okay.
Mm-hmm.
That makes sense. Yeah. So then it'd just be like 1, 2, 3. And then how would you get the 6? Sorry. So how would you?
So sample 1 is compared. I just put it paired with 2, 3, and 4. So that was 3 pairs.
Mm-hmm.
And then so sample 2 would then have to just be paired with 3 and 4. That's 5 pairs. And then the sample 3 would have to be paired with sample 4. So that would be 6 pairs.
Okay, yeah, that makes sense then. All right, so then it would be 6. Okay, thank you for connecting the dots for me.
You're welcome.
Awesome. All right, moving on to the next one.
I can read the next one.
Oh, sweet. Awesome. Thank you there, Clinton.
The data in soccer shoes was collected to help determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes, A, B, C, D, E. and also just wearing socks for a total group of 6. Each row represents a kick from 10 meters away from target that was hung 115 centimeters up from the ground. The column accuracy is the distance from where the ball impacted the target. The center of the target, so smaller numbers are more accurate. What is the minimum variance in 6 groups?
Okay. So we just have to compute or put in everything. Plug everything in.
Yeah, I got 27.208.
Yeah? Okay.
Let me know if you guys get that.
Right now. Man, I have so many windows open right now. Should probably close some of them. Gonna confuse myself. Okay.
I got 27.208.
Okay. Just a sec. All right. Yep. So I got 27.208. Is that all? I guess everybody got that then, eh?
Mm-hmm.
Yep. Perfect. All right. Moving on. Oh, go for it, man. Sorry.
Oh, sorry. I was just reading. What is the maximum?
The maximum. All right. Take a look. So I got 53.158.
That's what I got too.
Yeah? Okay, perfect. Awesome. Okie doke. Moving on. The test for equal variance is satisfied for these data. Sorry. The test for equal variances is satisfied for these data. These data. Wow. Okay, that's a little confusing. But I believe it would be true. Is that correct?
Yeah.
Yeah, that's what I think too.
Yeah. Just because the largest is not 4 times more than the smallest. Yep. Okay. All right. Question 11. Would you like to read that, Wendy?
You got it. Construct
Awesome.
a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plot. Are each of the samples normally based on what you see in the QQ plot?
Okie doke. Guess we'll just do that.
True.
Let's see.
I'm looking at number 6, and it doesn't look like it's normal. So I would say false.
Yeah, and that would be for the socks.
That would be the socks one.
Okay. Yeah, I'm just gonna double check that one right now. Do. Wow. Actually, I might just use the actual. I was trying to do my own, kind of messed it up.
Gotcha.
Yeah, I have to use the quantitative descriptive statistic Excel sheet. That made it super confusing. All right. There we go. Come on. Perfect. And then I need to put those in order. The data. Yeah, the sixth one does look a little bit. It looks a little bit off. Because if you look like where the 0 is, it kind of looks like it's going to split off a little bit.
Mm-hmm.
Yeah. So, I guess what would you guys want to say that is then? I mean, this is the part I'm a little bit confused about. Because all the other ones, they look pretty straight, but that sixth one, it looks kind of weird. Yeah.
Quentin, what are you thinking?
I don't know. Drew, maybe?
True, maybe. Sure. Well, I guess if we choose true or false, and if we realize whether it's wrong or not. That's right. When we go it the second time around.
Yeah.
That's for sure. So I guess we'll go for true right now. Or you guys do you do your best guess.
Okay, you got it.
All right. Awesome. All right. So question number 12. Yeah. Okay. Perform an ANOVA test in the SPSS and observe that the p-value is 0.081. Then remove the SOX data and perform the text again. What is the p-value when we remove the SOX data? SOX data. All right, so we're just going to remove that one. Okay. So I got 0.309. Did you guys get that one?
That's what I got.
Perfect. All right. All right. Question 13. Who would like to read that one?
Read.
Yeah. Thanks.
For an ANOVA hypothesis test is an F statistic. Is the p-value the area to the right or the left of the F statistic? I think it's right.
Yeah, I agree. I agree with that completely. Because I believe that for everyone, it has to be right skewed.
Right.
Yeah, that's right. Yep. All right. Next question. Would you like to read that, Wendy?
You got it.
Awesome.
Researchers at Consumers Report analyzed 3 types of hot dogs, namely beef, poultry, and meat. Mostly pork and beef, up to 15% poultry and poultry meat. For each of the 54 hot dogs analyzed, they recorded the types, the calories, and the sodium level. Their data is available in the file. That one, use the data file to answer the remaining questions. Let's examine the calories first. Construct QQ plots for the calories for each of the 3 types of hot dogs and compare the variances to determine if the assumptions are used for the ANOVA has been met.
Okay.
So we'll read through the rest of the options we have there. Let's do the QQ plots first.
Yeah, that's right. So have to do 3 of them. For calories, is that correct? Or sodium?
For calories.
Calories, okay. All right. Sweet. Well, this is going to take a while.
Uh-huh.
All right. So, beef. Wow. Did you guys take a look at the beef one?
I have not.
Okay.
Getting there.
No problem.
Okay, so I have the beef one up there. It doesn't. It follows the line, but it kind of goes around.
Yeah, that's pretty much what I'm seeing too.
Okay.
Yeah.
Okay. Let's move on to the next one.
Yeah,
Wait,
so,
which one do you think it is then?
so I believe, I think it would be the first one, wouldn't it? The assumption have that if it's safe to assume that each group. Oh, wow, that's not even the right question. I think. Am I reading the wrong question? No, that's the right question. Let's examine the calories first. Yeah, okay. I would think it would be the first one. The assumptions have been met. It's safe to assume that each group comes from a normally distributed population. And we can also assume that the variants are equal. Is that what you guys think? Or I'm not completely sure. It could be that one. But looking at the data, it kind of looked, yeah. I mean, that would be my guess, but I'm not completely sure about that one. All right, but I guess we can move on to the next one if you guys want to.
Okay, so were we supposed to write a QQ plot or do QQ plots for each type or for all of them together, all the calories?
I think it's for each type, yeah. So like pretty much for like the beef, for the meat, and yeah, for the other ones, yeah.
Okay.
Yeah, that's the part I'm definitely going to try to get more familiar with, because the QQ plot, I mean, I wish that they just had a better way of like a method of seeing if it's like not normally distributed. But yeah, I believe it'd be A though. 14 would be A. But what do you guys think? Do you think? I'm not completely sure, but that's my best guess.
I don't know, because they don't look normally distributed to me. So I don't know if it's more of like C or D.
Yeah, I agree with you. Yeah, because even for the last one, it looks kind of weirded out. And it's not completely straight. How about for you, Clinton? What do you think? My friend?
The 15th one, right?
Yeah, we're 14.
Yes,
Actually, yeah, so 14 we're still talking about. What do you think for 14?
I'm confused on 14 too. I marked it as A when I was doing it earlier.
Oh, okay.
I was still confused. I don't know if I'd go with A or.
Yeah, me too. Yeah. It's either hit and miss this one. That's for sure.
When I read all four of the options, A sounds more like likely to be the answer.
Yeah, that's true. Because it sounds like the most logical one.
Right.
Yeah.
Okay, A it is.
All right. Cross our fingers. Hopefully it is. All right, we'll move on to number 15. I'll read this one. Run an ANOVA test to determine if the mean number of the calories is the same for all three types of hot dogs. You should find that the degrees of freedom are 2 and 51, and that F equals 16.074, and that P equals 0.000, with the level significant equals to 0.05. What conclusion can you draw? We have sufficient evidence to the claim that all three hot dog types have the same mean number of calories. We do not have sufficient evidence to reject the claim that all three hot dogs types have the same mean number of calories. We have sufficient evidence to claim that all three hot dog types have a different mean number of calories. We have sufficient evidence to claim that at least one of the hot dog types has a different mean number of the calories than another type. So wow. Okay. So the P equals 0.000. Wow, that's a good question. I mean, I believe it would be the last one. Because, yeah. I believe it would be that one. What do you guys think?
Sounds good.
Yeah? Okay.
Yeah.
All right, so we're all okay, sweet. Okay, good. Okay. 16. All right. Clinton, would you like to read that, my man?
I can do that.
Awesome. Thanks, man.
Now let's examine the sodium levels. Construct QQ plots of the sodium level for each of the three types of hot dogs. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 718075, and the largest is 104192. 871, what is the assumption? Have the assumptions been met to use ANOVA?
Oh, wow, there's two uses. Nice. Somebody mistyped. I'm just kidding. It's all good.
I
Happens to
marked
everybody.
C for that as the answer.
Oh, I'm sorry. What was that, Clinton?
I marked C for that as the answer.
CA. Okay.
The assumptions have not been met. It's not safety.
Okay. All right. I'm going to attempt to put it into the QQ.
Okay.
We'll see what happens. All right. Okay, the first one kind of looks normally distributed. All right, the second one. Yeah, it kind of looks normal too. And the third one. Oh, I didn't copy and paste it correctly. Yeah, definitely the third one looks kind of messed up.
Mm-hmm.
So I think Clinton I think you're right, my man. I think it would be the second one.
Third one, you mean?
Third one.
Third one, sorry, frick, yeah. My bad. Yep, it would be the third one. And that be made, it's unsafe to assume that each group comes from one level. Yep. All right. So, question 17. Despite the possible problem with the Q plot for all poultry, you decide to use a ANOVA to determine if the mean sodium numbers are the same for all three groups. What is the p-value for the test? Okay, so it's just for those three. Okay. All right, so I got 0.179 for
Yep.
that one. Yep, perfect.
Yep.
How about you, Wendy? Did you get the same one or?
No, I haven't done it yet. So, but if you both got it, we're good.
Okay, no worries. Awesome. Okay. And who would like to read the last question?
I can do that.
Hey, thanks, man.
What conclusion can you draw about the mean sodium levels of the 3 types of hot dog? Use a level of significance of mean as 0.05.
Okay.
I think it is B, but I marked.
Sufficient evidence to reject the claim that all three have. Let me just double check. Okay. So, so you said it was the second one, eh, Clinton?
That's what I think it is, yeah.
Yeah. Okay. Do you think would it be the first one though? That we have sufficient evidence to claim, because I believe, you may be right. I'm not completely sure, because like the p-value is more than 0.05, right? So that means that we wouldn't be able to reject it. Or maybe I'm confused right there. What do you think, Wendy?
When I think it might be A because you don't reject it unless it's lower,
Yeah,
right?
I believe so. Yeah, because I believe that the p-value, since it's higher than 0.05, I believe. I mean, you very well could be right too, Clinton. But I believe that since the p-value is higher, it would be A.
So we have significant.
Yeah, but we shall see, man. If it's not right, then you're definitely right.
Hold on, I just closed the browser. Mistake.
Oh dang! Hopefully it all saved.
Yeah, I wrote the answers in the comment, so it shouldn't be too bad.
Yeah, that's right. All right. All right. Well, guys, do you have any other questions regarding the tests at all, or?
No.
No? Okay. All right. Well, I guess that would be all. I'm just double checking just the answers right here. Yeah, I think we're okay. Yeah. All right. Well, other than that, I guess we're good.
Right.
But well, good luck studying for the exam. And Wendy, I hope that everything works out with that situation. That's pretty
Hey,
intense.
I'm sure it'll be fine. We will. The company will eat that $60,000. But yep.
Yeah, that's crazy. Wow, that's nuts. I mean, even where I worked, like I wouldn't think that would ever happen. But frick, there you go.
Yep.
Hey, well,
Crazy
hey,
things.
all good.
It'll work out.
Yeah. Well, I guess everybody's good for Thursday. Same time. Everybody's good with that. As usual. Yep, perfect. All right. Well, guys, you have a wonderful week, and we shall see you all on Thursday for sure.
Yeah.
Alrighty.
All right. So hopefully you guys got the right answers. Hey, take care, guys, and good luck, Wendy.